Okay. Anyone still not taking their score? Yeah, please check. Yeah, please. Okay. And I think, have I put the answer key for this one already? Right? Okay, I think I just want to emphasize first several parts here. I think mostly like the radius, interval convergence, finding which one diverge and converge, testing. Okay. Also the Maclaurin series. Okay, it's always every midterm it's always been asked. And here, usually I ask about like this one, okay, finding the area, finding the arc length of the polar curve, okay, and yeah, the sum of the series, this one, okay. Okay, I have another type, okay, besides this, so I think we can try that one. You can check the answer key for this one in the Moodle. Okay, I have put, I think, yesterday. Wait, where did I found it? Oh, this one. So this is another type. It's supposed to be similar but different questions. Okay. So maybe we can start from number one. Okay, number one, asking slope of the tangent line. Okay. Slope of the tangent line. So what the question is asking actually. So here we have the slope, but we have the polar, right? We have the polar. So we have r equal function of theta. Okay. So actually, if the question is asking the slope of the tangent line, which means we can represent the polar curve in terms of x and y, right? R cosine theta, r sine theta. So we know x, we know y. The slope means it's the same every time the question is asking about slope. It is about dy over dx. Okay. So it's asking dy over dx. Okay. So we can think this dy dx based on our parametric. So I'm going to write here. So dy dx is dy d theta over dx d theta, like that. And x and y we can get from x is r cosine theta, y is r sine theta. And then we need to differentiate this two with respect to theta. Okay. So we are going to have, for example, here x become 2 plus sine theta cosine theta, and y is 2 plus sine theta sine theta. Okay, this is from the R. Okay, from the R. And I believe you can derive this too, and then put into this equation, and then we put theta equal pi over 4. Okay, simple, right? So I hope everyone can get a point from this one. Okay. So that's number one. Number two. Oh, which? Okay, this one? Yeah. Okay, that's for number one. Okay, number one. So I hope you can derive and then find out the slope. Okay? And then don't forget to take the theta equal pi over 4. Okay? If you need this answer key, I will put the question and answer key so you can learn at your home. Number two is actually quite a little bit, the difficulty is higher. So if you are finding this type of question in your exam, you could skip first. Okay? You could skip first. But for number one, this is the question that you need to be, I expect you to answer this. Okay? Number two, this is the functions defined by h. We have sine p over t. If t is not 0, the h at 0 equal 1. And then we have another function we call f, which the integration of this, okay, integration of this h from 0 to x. Okay. So this is, if you remember, this is fundamental theorem of calculus. Okay. We have 0 to x, but here we have another variable to compute. Okay. So at the end, we are going to have an x expression or expression in variable x. Okay. And then suddenly the question is asking, this f5. If you remember, this is coming from the Maclaurin. Right? Coming from the Maclaurin, we derive 5 times, and then we put x equals 0. Okay. Now, what we should do on this number? First, we know that the f of x is the equal to this, right? So by fundamental theorem of calculus, we can derive this, and then we can remove the integrations, which means this is equal to hx. Or we can implement inside the function itself sine x over x. In which we know that in Maclaurin, sine x is something that we expect to know, okay? Something to know. Okay? So x, right? This is the sine. Right? And then all that divided by x. So it's become a new series in which all the terms are going to, all the x terms will get in -1, right? So -1, or here's cancelling. This is -1, so it's become squared, become 3, 4, and so on and so forth. Okay. So we can write here that the sine x over x is that, or we can simplify it. And then this is, we say that this is the f prime x, right? This is f prime x. So we need to do a little bit repetitions. Okay? We need to do some repetitions. So this is actually the f prime x. Okay. So how about if we take the second derivative? If we take the second derivative, this will be 0, and then this will be 2x, right? And then this will be 3 by 2, and then we can cancel this. So 1 over 3x, and then we have another one, so it's still dot like that. So the x cubed become 3x squared, and then we have 5, 4, 3, 2, right, and 1. Okay. Oh, I think this is 4. Sorry, this is 4. So minus 1, right? So this will be 4x cubed. We can cancel 4, and then I don't want to count this, but this will be that. Okay? And then try the third one. This will be negative 1 over 3 plus this will be 3x squared. But we have now 5, 3, 2, 1, and then canceling 3 like that. So we have 1 over 10. So basically we are climbing 1 by 1. And then we take the 4. They become 0. This will become 2x and 5, 2, 1, and then canceling. Okay. So at the end, we get the f derivative 5, which is 1 over 5. So when x0, it's 1 over 5, because the whole thing in this part here will be 0, right? So this will be plus right? So f at 0 is 1 over 5. So 1 over 5 is d, so it's d. Okay. So actually the series, like the Maclaurin, is actually quite helpful to solve some problem in math. Like this derivative, you can derive all the expressions, or if you have limit, you can also change some expression in limit using the series, and then you can, at the end, after you solve or simplify the equations, you plug in the limit, and maybe it will help to get a solution. Okay. Okay, I think for the radius of convergence and then interval of convergence, that is the one thing that you should be able to solve. I expect most of the students can solve it. Okay. So finding the radius convergence, first find ratio, take limit, and make it converge by taking the value less than 1, okay, less than 1. And you get the radius, right? Okay. I think yesterday we talked much about the some converge diverge. Okay. Which one do you think? This is the one that appeared in your quiz, right? So sometimes I recycle the series. Okay, maybe let's see some of the questions first. Okay, how about this one here? For the part B, and anyone think which one should we discuss first? Which one do you think that you need right now? Which one? Number 7. Oh, this one? Okay, this one. Okay, let's say we go to the chapter 10. That is the area of the shaded region. So, first, the shaded region is the blue one. Okay, the blue one. The key first is to find the interval, to find the endpoints, because we are expecting to take the integration of this. So how to find the points? At least we know that the intersection is here, right, at 0, which means when r equals 0, this will be the point, right? So we can take that and we can find the theta, at least with the theta. So when r is 0, we can find that sine theta is equal 1/2. Okay. So theta will be at least pi/6 in the first quadrant, and then maybe in the other quadrants we can add 5/6 pi, 13/6 pi, and so on. Okay. Okay, now how to evaluate the area is basically we are going to take the whole area, including the little one here as one area, okay, and then we are going to minus with the small one. So remember, in polar, the theta start from here, okay, and then we move, and then we go like that, right? So we can say if we take this, then without the middle one, then it is the cardioid, if you remember, like the heart structure. So imagine this is the blue, all blue. Okay. So we could take area taking from this point up until this point again. So we can say, or perhaps if we take let's say we take this 5/6 pi to 13/6 pi. Okay. So let's say we are going to take this 5/6 pi maybe around here, and then it will rotate up until 1/6, or 2, this is 2 pi, right? This is 1/6 pi. So it goes back to here. Okay, so it's back to here. But actually, if you take, maybe you take pi/6 to 5/6. I don't think it's looped. Okay, you need to make sure. Okay, you need to make sure that the whole thing is going to full circle. Okay. So imagine that if we take from here, from 5/6 pi, from this point, we start, okay, and then we end up here, which is actually pi/6, but because it's getting higher, I will choose that as a 13/6 pi. Okay. So I will write the first expression from 5 pi/6 until 13 pi/6. Half, this is the r. R is 1 minus 2 sine theta squared d theta. And then minus the small one. The small one is actually, we can start from pi/6. Okay, so pi/6 is around here. This is pi/6. This is the 5/6. And also 13/6/pi also here. Okay. So we take from pi/6, and then we are going to rotate up until 5/6 pi. So it's actually from here, and then there. Okay, I hope you can imagine. Okay. So that will be the loop. Okay. So then we can write from pi over 6 to 5 over 6 pi. And then the same 1 minus 2 sine theta squared, and then d theta. Okay. The key important here is always make sure that you start from this polar axis. You start from here and like that. Okay. So if we take the whole thing as a loop, imagine that from the 13.6 over from the 5 over 6 pi, we start from here and then ends here, which means that is the first one. The second one we start from here and then end up in here. Okay. I hope you can visualize and imagine that. Okay. Because this loop making this polar a little bit difficult to visualize. Okay. Okay. So why I'm choosing this 13 over 6 pi? It's actually the same as pi over 6. But I'm choosing 13 over 6 to give you an idea that we start from 5 over 6. If I choose pi over 6, it means that it's the same as the beginning. Okay? I'm adding to 13 over 6 to give you a sense that it's moving towards this direction. That is adding at least almost to full circle, okay, 2 pi. Okay, I hope you get the idea of that. Okay? And the rest is solving the integrations. Okay? Solving the integrations. The best way, my suggestion for you, whenever you have this squared, after you get some expansion, my suggestions is using the trigonometric identity to help you solve the integrals. So let's say this is the identity you usually have. Okay, you see that we have the sine squared. So you can turn the sine squared and making this one. If you integrate this, it's easier, right? In this form. Okay. Because we expect when we derive or when we integrate this, we have the squared here, right? This is the sine squared. So we are going to have 1 minus cosine 2 theta. Or in our case, we have 4, which means we need to multiply by 4. So 2 minus 2 cosine 2 theta. So for example, this one becomes, so this is 1 minus 4 sine theta plus 4 sine squared, right? So this can be written as 1 minus 4 sine theta, and then change to that plus 2, maybe 2, plus 2 minus 2 cosine 2 theta. Okay. The rest is calculations. Okay? If you get this right, the first step's correct, it's already a lot of points. The rest here is just calculation. Sometimes you make mistake, it's okay. But I hope you get the idea correct. Okay? The idea correct. My suggestion, if you're still confused about this polar, you can look up some tutorials about polar curves, how to start drawing the polar curves, how to take which one is the theta, okay, and how you started. Because basically, how you understand the polar curve is basically taking some theta here, and then imagine that which one is the r. the R is changing, right? So in every point, let's say it starts from the polar curve here, which means we have here, which means when sine is 0. So this will be 1, and this will, at least this is 1. This is another 1, okay? I mean distance. So this is 1, this is also R equal 1. Okay? And then we need to know how much is this, how much is this. Okay? You can check with some theta. Okay, we can check some theta. You can check some special value, maybe the first quadrant, the second quadrant, the third quadrant, to see how it goes. Okay? And you will find in between this 5/6 and 5/6 pi, you will see that it's actually looping here. Okay, looping inside the small one. Okay. That's how you can confirm the distance, the radius. Okay, I hope you can compute this. Later I will put also the answer key for this one. Okay. Okay. Okay, any other question? Which one do you think we need to discuss? 11, you mean, oh, this one? This one? Yes, it's challenging, right? So it's square root of 3, 9, and then become 45, and become 189. Maybe this is 1 and then 9 and then 45. We need to find the connection first. What is 189? Why it's appear? Okay, so starting to number 11. Okay. Okay. So it's actually quite interesting. Do you want to try first? Let me give you like 2 minutes, 2 to 3 minutes. This square of 3 may be the key. And then for the 189, maybe if you try to define by 3 or 9, can it be? It can, right? You can define it by 3 or 9. So maybe you can find something. And then adding the alternate, you can add it -1 with power, right? To get alternate series. Okay. Maybe finding the pattern first. Like, don't need to go here. Just look at the number and maybe how to relate from this to this to this. Okay. Any idea? Oh, you get it? No? we can think 189. What is relation 189? No? Maybe? Yeah. You get the idea. So it's actually, if we take, so let me write here, or maybe just directly. So if we look at the square root of 3, okay, it's all have square root of 3. So the idea is to find the pattern. Okay, so we see this 9. Okay, it's 9 is 3 squared. Okay, this one is 3 squared by 5. And how about 189? If we divide by 9, can we divide by 9? We can, right? Yeah, 21. So it will be 21. So if we divide by 9, it's 21. Okay, but 21 is 3 by and 7, right? So we can take cube and then this will be 7. Okay, still it's not really complete yet. Somehow, if we take the definition that if the 3 is actually square root of 3 squared, right? So how will we make all the square root of 3 becomes our main idea? So this square root of 3, let's say this is square root of 3, 1. Right? So if we make square root of 3 squared, for example here, if we take this square root of 3, so this is, let me write in the new one. So we have square root of 3. Now I would like to make the second one square root of 3 squared. It would be 3, right? And then 3 squared. But it seems, after some observations, I will make this with cube. Okay. If we take this cube, then we have square root of 3. Square root of 3 is 3. So 3 square root of 3. So we need to multiply with 3 to make it 9, right? So to make it 9, we need 3. Okay. And then another one, since we start on 1, 3, I expect to be 5. So I will take this and make it with 5. So square root of 3 until 4 is 9. And then 9 square root of 3 to become 45, we need to multiply with 5. Right? So we are going to take 5 over here. So if we multiply, we have 45. The same thing, I expect to have 7 here. So I will multiply 7 with square root of 3 with power of 7. Okay, since we have this is the cube, so this will be 7 and then square root of 3 with power of 7. So we get that this will be based on what we have here. We can write the alternate series first. So -1, since it starts with positive, we take n, okay? And then we have on the bottom side, we have 1, 3, 5, 7. That is the odd number. We can write that. And then we have 1 over square root of 3. That is our main idea or our variable, right? And then or maybe let me write, maybe this first. We power this to odd number, to n plus 1, right? Or we could see the whole thing as this is actually tangent inverse x. So basically, this will equal to tangent inverse of 1 over square root of 3, which equal to pi over 6. Okay. Interesting. At least something like this, you need to be able to rearrange. Like for example, if this is not exactly like this, but you can erase that. I expect you can relate something like this with the Maclaurin functions. So either it could be sine, cosine, the ln, or the tangent inverse, or e to the x. So I already give you a clue for tomorrow. So this midterm is pretty much more difficult than tomorrow. Okay? So tomorrow will be not as difficult as this one. Okay?
Every professor says that.
Oh really? But I assure you, not this way. Okay, not this way. Okay, which one do you want to take to discuss again? Any number? 9? 9A. Okay. Oh yeah. Last year, many students doesn't get what this means. It means that we multiply 3, 5, 7. It's not changing whole this become this. So we need to multiply this much. I mean, this is odd number, right? So every odd number we multiply. That's how it means. What it means, right? Up until like infinite number, right? So basically, what you can do to find this?
Ratio test.
Yeah, ratio test. Okay. So we take here, taking the an plus 1, okay, and since we have absolute value, so we can remove the negative 1 first for our ratio test. So an plus 1, it will be, so let me draw this. So this will be n plus 1 factorial and then 3 with power of n plus 1. And when n is n plus 1, so this will be 2n plus 1 plus 1, right? So you will have 2n plus 3, okay, 2n plus 3. So, which means we are going to have 3 multiplied by 5 by 7 by da 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 da, and then 2n plus 1, 2n plus 3. Okay, that's for an plus 1. And multiply, this will be n factorial and 3 with power of n. And then 3, 5, 7, da, 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 and then until 2n plus 1. And we are going to see many cancellations. So canceling here, canceling there, right? And then canceling here and canceling there. Canceling here, here, and left. 3 is as a leftover. So we take limit. We have 2n plus 3, right? Over 3 n plus 1. Okay. So this will be equal to 2 over 3, right? Which means that this is less than 1. So you could say that this will be converged. Or in our case, we can directly write this is absolutely convergent. Okay. The arc-length function in parametric, I hope you know how. At least tomorrow, similar composition will be 10, 11, but 11 a little bit more. And I will put all this answer key later on, okay? So you can study again. And my point is to get to this question correct is you need to understand the concept, basically. So read the questions. If you don't really understand what it is, it means that you don't really understand the concept behind it. So my idea, if you want to study more for tomorrow, although so I think not good if you study like until late because tomorrow is morning, right? Maybe just make sure that what kind of question that you're still confusing, okay? And maybe you can try to make up by some reading of my explanation here. Okay. Okay. Any other discussion from here?
Can you do 9B?
9B. Okay, 9B. 9B is quite interesting. So it has the ln, and then it has 1 plus 1 over square of n. If you take the limit, it will be 0, right? If you take the limit, it will be 0 because this will be 0 and ln 1 is 0. I see some students still write limit 0 converge. Not true. Okay, not true. Not all limit when you take the series with the limit n. If it is 0, you need to check with another method. Okay. But if you take limit, you get the number. or you get it doesn't exist, then it's diverged, for sure, diverged. Okay? But if you take limit, for example, this one, you take limit, you take here it's 0, and then ln1 is 0. It's 0. But is it converged? It's not converged. It's not true. Not all limit that can 0 is converged series. For sequence, it's converged. You need to differentiate. There are sequence, there are series. Sequence is just a pattern. But series, we are adding. We are plus, 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 plus. We add all the terms, right? So, any idea which method we are going to take this one? Sorry? Root? Do you see any root? Only this one, right? But how do you make this one? The root test can be applied if you see any power that is quite big, which usually is power of n. So the root test is actually you are rooting all the terms with n power. Okay? So my suggestion for this one is to take the limit comparison test. It's quite simple actually. So limit comparison test, so let's say this is our an, okay? The whole thing here is our an. And let our bn is 1 over square root of n. Why? Because we expect that at the end of the day, we are going to canceling each other. And we know this series, right? This diverge, right? This diverge. So we are expecting that perhaps this is also diverge, okay? So we can start to take the limit. So how we are going to take that? So limit, and we are going to take the an over bn like that. So what is the limit is what? N ln 1 plus divide by 1 over square root of n. Now we need to have some understanding on limit, okay? Take here into inside, infinity inside, we get 0, okay? Take the down part, also 0. We have 0 over 0. So we can get what? Yes, L'Hopital rule. Okay, L'Hopital rule. Correct. So take L'Hopital rule. So this is just my summary. Okay, this shortcut. Okay, shortcut. Every time you see limit, you see ln, it must be L'Hopital rule. You can check every question in calculus book. Every ln you have limit, it's L'Hopital rule. It must be, unless maybe it has some unique mathematical structure that maybe not easy to L'Hopital. But mostly all the calculus, you have limit, you have ln, L'Hopital rule. Okay? But you need to check first, 0 over 0 or infinite over infinite. Then you can take L'Hopital. Okay? So take L'Hopital. It means we are differentiating the top equation and the bottom equation. Okay. I think you can take this, right? And then chain rule. This will be right, and then this will be minus, and then minus half minus 1 is 3 over 2. So you see that this cancel, right? So we have this equal 1. So since it is a positive value, then we are going to know that this will be divergent, because this series diverge. Okay, time is up. I will give you the rest of the key later. Okay.